Hello everyone, this is Sri Banerjee, and I'll be lecturing on quantifying and comparing epidemiological measures in this session. So I'll be going over multiple concepts in this session. There's a lot of calculations involved, and honestly, epidemiology entails simple calculations and for the reason of comparing different measures. And it's oftentimes confusing which formula goes where and where a certain formula is appropriate. But I'll try to show you in a systematic manner, in a logical fashion, how to approach certain epidemiological measures and where each measure is appropriate. So first I'll be going over some basic concepts about what a ratio is versus rate versus proportions. Then I'll go over morbidity versus mortality, incidence versus prevalence, and then I'm going to hone in on direct versus indirect adjustment death rates. Now, I won't be able to go over all of these in one session, so the recording will be done in multiple sessions. So to start off, this is a wonderful figure that's in your Fris and Sellers book, and this is a breakdown of what a ratio represents. And as you can see, in epidemiological measures, you can have counts. So you can at the simplest level, really, count the number of individuals that have a certain disease, and then go from there. However, ratios make more sense. Logically, ratios make more sense because you're able to compare certain measures if there's a ratio. Now, there's different types of ratios. There's proportions, and then there's rates. And a lot of times there's confusion between proportions and rates. Really, it's a matter of semantics, but a lot of times you'll see people write prevalence, rate, incidence, rate. But in actuality, a prevalence is a proportion. Now, I'm not going to go over the different types of prevalence, but for the sake of completion, in this diagram, there's point and prevalence and period prevalence. Now, rate, which usually has to do with time, some sort of time, is usually depicted by incidence rate. I'm going to go over this a little bit more in this lecture. So let's look at a ratio to begin with, and this is a simple ratio. It's the ratio of males to females, and this is actually the number of males per 100 females. It could be males to it could have been males to females, and then it would have been less. The ratio would have been less than 1. However, because it's per 100 females, you're actually multiplying this ratio by 100. So, as you can see, the sex ratio in the year 2010 was 96.7 males to 100 females. So, demographically, you will always see that there's more females than males, and the reason being is that due to higher life expectancy. So this is a very simple example of what a ratio entails. Now, a proportion is a measure that states a count relative to the size of the group. So I'm going to give you an example. Sometimes it might not be as clear what it means. Proportion, here in the next slide, proportion is one versus the other, is account relative to the size of the group, but rate is a ratio that consists of a numerator and a denominator in which time forms part of the denominator. So for instance, disease frequency, unit size of population, and time period are three components of a rate. So this is the comparison between proportion and rate. I hope you are following me so far. So going back to this slide, we've gotten down to the proportion versus the rate. So rate involves time in the denominator. Now I'm going to jump to talking about prevalence versus incidence. And like I said, incidence actually takes into account time. That's why it's more considered a rate. So the number of existing cases of a disease or health condition in a population at some designated time versus the number of new cases of a disease that occur in a group during a certain period, so a certain time period. And that's the difference between the prevalence versus the incidence. So if you have been to a waterfall, this is a gorgeous waterfall, and it actually brings home the point that in what the difference is between the incidence and prevalence. So if you look at prevalence would be considered the pool. So it's all of the water. I mean, it could include time period, but it's all the water that is collected at the pool. Whereas incidence is the water flowing down the waterfall. So this is all the new water falling down versus the water that's collected. So the uses of prevalence, where is it most applicable? Describing the burden of a health problem in a population. That's where prevalence is very applicable. But then also estimating the frequency of an exposure, determining allocation of health resources such as facilities and personnel. These are all wonderful uses of prevalence. So here, this equation sums up very, in a succinct manner, what the relationship is between prevalence and incidence. So prevalence of a disease is proportional to the incidence rate times the duration of a disease. So this is one of those equations, one of those fundamental equations of epidemiology that you really want to tuck somewhere in the back of your head and really remember, because this is something that comes up again and again. So if you can, as you can see in the equation, if duration of disease is short and incidence is high, then prevalence becomes similar to incidence. So basically in this equation, if D comes close to 0 and incidence becomes really high, then the prevalence and incidence are similar to each other. So short duration, when there's cases recover rapidly or are fatal, that's an example of where duration can be short. So the common cold can be a good example of where prevalence and incidence are close to each other. So just to sum up what we've gone over is the difference between prevalence and incidence. That's the main concept that I went over. And again, prevalence is a proportion and incidence is a rate. And so because incidence takes into account time in the denominator. So in the next session, we'll be going over all the different types of morbidity, mortality rates, and we'll be going over some other mortality, adjusted mortality rate measures. So thank you for listening.